we'll be changing molecular name to chemical formula. We have hydrofluoric acid. Now, as you can see here, we see that hydrofluoric acid has acid, and there's the word hydro. In this case, this means that there's a hydrogen, every time there is the word hydro in the beginning, you need to know that it's a hydrogen and a halogen. And halogens are here. They're fluorine, chlorine, bromine, iodine, and so forth. And so here we have hydrofluoric, we have fluorine here, so it is HF. Phosphoric acid, like the previous example, we have the word acid in it, but we don't have the word hydro in the beginning. Now, every time there is the word acid, keep that in mind that there is a H in the front, but the rule is if there is no hydro in the front, you have to look at the common ion. The rule for acids, the common ion, is if the common ion ends with an 8, the ending of the acid is ic acid, and when the common ion ends with an ite, the acid has to end with an us acid. So we have phosphoric, change that to phosphate, and the chemical formula for phosphate is PO43 minus. And so when you add a hydrogen and a phosphate together, hydrogen has plus charge, and so to balance it out, it needs H3PO4. Chlorous acid, again with acid, so we know that there is a hydrogen. And as I said, chlorous, the rule is if the common ion ends with an ite, changes into an us acid. So chlorous is chlorite, and the chemical formula for chlorite is ClO2 minus. And when you add a hydrogen and a chloride together, they cancel out and it becomes HClO2. Now we have lead for bromide. When you look at lead in the periodic table, you find that it's right here. And every time that there is a Roman numeral, this pertains to the charge for a transition metal. So we have here a transition metal and bromide, which is a non-metal. We have Pb with a charge of here 4 plus the Roman numeral, and bromine has negative. So in order for lead, the charge for lead and bromine to cancel out, to balance out, you need 4 of bromine. Potassium sulfite. Potassium in the periodic table is K here, which is a metal. We have the charge of K plus. Sulfite, the chemical formula for sulfite is SO3 2 minus. And when you put those two together, you need 2 potassium, SO3. Silver acetate. Silver in the periodic table is right here. It's a transition metal. So we have a metal, Ag, and there's no written charge, so we're just going to have it as Ag plus. And the chemical formula for acetate is C2H3O2 minus. And when you balance those two out, it becomes Ag C2H3O2. Tetraphosphorus trisulfide. We have phosphorus, sulfide. When you find those in the periodic table, notice that they're right here. There are 2 nonmetals, so we have covalent compounds. Now, the rule for covalent compounds are different from what we did previously with metal and nonmetals. With covalent compounds, we need to basically write down the number, count each element, using the words mono for 1, di for 2, tri for 3, tetra for 4, and etc. So here we have phosphorus is P, we have sulfide as S, tetra is 4, tri is 3. So we have phosphorus, tetraphosphorus, P4, trisulfide, S3. Dichlorine octoxide, chlorine and oxygen. We notice here, it's right here. Again, we have covalent compounds. Chlorine is Cl, oxygen is O. Di, 2, octo is 8. So we have Cl2, octoxide O8. And there we have it.